that part is called sample. Each sample is represented by a binary number, and then these binary numbers are transmitted serially. So, the number of levels available means how many levels are available. It depends upon the number of bits which are used to express the sample values. So, if m bits are used, means suppose if 2 bits are used, then the number of level is 2 raised to power 2 means 4, that is capital N. So, number of level is equal to 2 raised to power number of bits used. If 3 bits are used, then the possible available levels are 8. 4 bits are used, available level is 16. Because 2 is the base or radix of the binary number, that is why 2 raised to power number of bits comes the number of levels. So, the 3 steps which are followed or performed in case of pulse code modulations are: first is sampling. First step is sampling, means the analog signal is sampled. Second is quantizing. Quantizing means assigning the levels or references to these samples, and third is binary encoding, means then assigning the codes to these levels. So, these are the 3 steps which are performed in pulse code modulation. So, these steps are performed in sequence for pulse code modulation. So, before we sample, we have to filter the signal to limit the maximum frequency for the signal. So, this is a general circuit. Low pass filter is generally used at the initial stage in PCM. So, filtering should ensure that we do not distort the signal. So, filter should be design of filter should be such that it should not distort the signal, it should only remove the high frequency components that affect the signal shape, it should not create distortion in the signal. So, these are the diagram. So, upper one is the transmitter in case of pulse code modulation, middle is the channel or the transmission path, and the last one is the receiver. So, first block is in case of transmitter, let us discuss transmitter. First block is source of continuous time signals, means this is the signal, then low pass filter is used to filter high frequency signals, then sampler means sampling circuit, then quantize means quantizing circuits, then encoder which is used for encoding means generating pulses, then this PCM signal is generated, that signal is applied to the channel. So, distorted PCM signals produced by the channel. So, distortion is attached with the signal. Then the regenerative repeaters, different repeaters, number of repeaters may be used in the channel for regeneration of the signals. Then at the destination end, the regenerated PCM signal is applied as final channel output. So, again here a regenerated circuit is used, then decoding is done, means reverse of encoding, decoding is done in case of receiver for demodulation. Then reconstruction filter is used, which reconstruct the samples, and the original at the destination the original analog signal is received. So, this is a just block diagram of 3 important sections. So, let us discuss these 3 techniques one by one. First, sampling. Sampling is the process of generating pulses of 0 bits and of amplitude equal to the instantaneous amplitudes of analog signals. Means the samples are generated, the number of pulses per second is called sampling rate, that is Fs, we discussed this already. So, in case of pulse code modulation, sampling is done first, then quantizing. So, quantizing is the process of dividing the maximum number of analog signals into a fixed number of levels in order to convert the PAM into a binary code. In this case, the levels are assigned to these samples. So, levels are the reference levels are assigned to these samples. So, the levels obtained in this case are called quantization levels. So, now let us look at this diagram. So, this is voltage diagram, means that is message original information. Then here this magenta color vertical lines are samples, means this is sampling. The analog signal is sampled at the intervals of Ts, which are shown in magenta lines. Then blue color horizontal lines are the levels, means that is quantizing. These levels are assigned. So, then levels are numbered from 0 to 7. 0 to 7 means in this case 3 bits are used. So, 3 bits have 8 possible combinations that are represented as 0 to 7. So, in the right side the binary codes, that is encoding, is done. Each reference level is assigned as a code. Bottom 0 number reference level, bottom line is assigned as 0 0 0. Then first level is 0 0 1, second level is 0 1 0, then 8th level is 1 1 1. So, in the normal binary sequence. So, this is the train, pulses train, final data generated, final PCM signals. So, in this case, so if you look at the first sample, so its level is second. So, means 0 1 0 is the code, is the binary code, that is encoding. Then the second level is 1 0 1, means its level is at fifth level. So, its code is 1 0 1. Then next is 1 1 0, 1 1 0 means sixth level. Then 1 1 1 means seventh level, that is the highest vertical sample. Then again 6 1 1 0 and so on. So, in this case the 1 is represented by a pulse and 0 is represented by a 0 means not pulse. So, a pattern like this is generated. This is the final pulse code modulated signal. So, this is a just block diagram, again that same thing is shown. Analog signal is applied to the sampling, means applied to the circuit which performs sampling. So, at the output of sampling these samples are performed, which are shown PAM signals. Then these samples are quantized, means the reference levels are allowed to these samples, that are shown in the upper part, that is quantized signals. Then these encoder converts these quantized signals into a binary form, means each level is assigned a binary number and this number is, that number is transmitted serially, that is digital data. So, this technique is pulse code modulation technique. So, quantizing, as I told earlier, the quantizing is the method of converting analog signals to PCM, means assigning levels. So, since the original signals can have an infinite number of signals levels, so in the original signal, in the continuous signal, the numbers are infinite. So, we cannot allow infinite levels. So, the difference between these two is called quantizing errors or quantizing noise. So, these are two techniques of quantizing. First is mid-treat, second is mid-rise. Difference is at the baseline. In case of mid-treat, the baseline is horizontal at the horizontal line, and here the vertical level is performed in the middle. So, then coding and decoding, the process of converting an analog signal to PCM is called coding. In case of coding, the codes are allowed to these signals, these quantizing levels. The inverse, which is performed at the receiver end, is the decoding. So, this is coding. Again black color is the analog signal. Vertical lines TS, 2TS, 3TS, 4TS, these are sampled, and the horizontal lines are the reference levels, that are quantization level numbers 0 to 7. Then each quantized level is assigned an binary code, so that is called encoded. So, that encoded information is transmitted serially, which is shown in C. So, that is the final pulse code modulated signal. So, this is the difference, it shows the quantizing error. So, black color is the original message signal, then dotted lines are the pulse amplitude modulated signals, then the dark lines are the quantizing levels. So, if there is a difference, in this case the quantization noise is shown or error is shown. So, first normalized values are shown, then normalized quantizing value means standard values are shown. So, for example, if value is 1.22, but we rounded off this value to 1.50, then the normalized error is 0.38. The difference between the standard value and means the allotted value and the original value is the normalized error. Then each value has a quantization code, then each code has a quantization code, means a level from 0 to 7, each level is allotted a code. So, quantizing error is same. When a signal is quantized, we see that error comes. The coded signal is the approximation of the actual amplitude, means it is not actual, it is the approximation to the actual, because analog signal has an infinite number of levels and we convert this infinite number of levels to finite numbers. So, this error comes. So, the difference between The actual and the coded value and the midpoint is referred as the quantization error. The difference between actual and approximated value is the error. The more zones, the similar delta difference result in smaller errors. So, it is just a diagram. In this case, round off errors and overload errors are shown. So, here the quantization noise is shown. In this case, the dotted line is the original signal, that is input wave, our original information. Then the solid lines or dark lines are the quantized outputs, means these are the quantization levels which we assign to the original signals. So, the difference between both two, which is shown below, difference between curves 1 and 2, that is the error, means curve 2 is not exactly like curve 1. So, the error comes. So, difference between these two is error. So, in PCM system, n number of binary digits are transmitted per sample, hence the signaling rate and the channel bit width of PCM is very large. In this case, the number of bits transmitted are more, every level is assigned a bit. So, sequence of bits is transmitted, means channel bandwidth required is large. So, also encoding, decoding and quantizing circuitry of the PCM is little bit complex. So, that is why we use the next technique, that is called delta modulation. So, delta modulation is the next technique which is better than this PCM. So, in case of delta modulation, only one bit is transmitted per sample, only a single bit is transmitted instead of 3 or 4 bits. For that bit is a 1. If the current value of sample is more positive than the previous sample, means those two samples are compared, the sample is compared with the previous sample. If it is more than or if it is higher than the previous sample, then 1 is generated and 0 is generated. If it is negative, means if the sample is smaller than the previous one, then 0 is generated. So, only a little information is transmitted in case of delta modulation, means delta modulation requires higher sampling rate than PCM. Here in this case, the sampling rate required is higher, means we should sample closer, as we compare only the samples and we will not generate code for each and every sample. So, the scheme sends only the difference between the pulses, it does not send pulses, it sends the difference between the pulses, that is why it is called delta. Delta is used to represent difference. So, a pulse at time t n plus 1 means present pulse is higher in amplitude value than the previous pulse, that is t n, then a single bit say 1 is used or it is transmitted, it indicates that the it is a positive value, means the signal is higher. So, if the pulse is lower than the previous pulse, then the 0 is transmitted. So, this scheme works well for small changes in signal value between the samples. So, where the changes are small, means there are very less changes between the sample, this scheme works very well. If the amplitude changes are large, then this scheme results in errors. So, here it is shown. So, magenta color is analog signals, then below is generated binary data in case of this. So, 1 1 1 1 means the signals are increasing, means the samples are increasing, 0 0 0 means the samples are decreasing. So, this is the diagram, it is simple diagram. Analog signal is applied to the comparator, the output of comparator is taken as feedback and these two samples are compared and either 1 or 0 is generated. So, again same diagram shown, first is transmitter. In the case of transmitter, same comparator is used, feedback is taken and compared at the comparator and a pulse is generated, that is encoded. In case of decoded, the same reference signal, these two signals are delayed and a resultant low analog signal is generated. So, distortion, here also distortion occurs. If the slope of analog signal is much higher than the approximated digital signal, then the distortion difference occurs is slope overload distortion. The second type is granular noise, that is the difference between quantized signals and the original signal, that is called granular noise. So, this is just shown in with the help of diagrams, the two type of quantization errors are shown, slope overload distortion and granular noise, these are shown in this diagram. Thank you.